And you found the quick review, and this is Introduction to Quadratic Functions. So a quadratic function, when graphed, will have the shape of a parabola. And that parabola can be in a couple different ways, right? This is a minimum, and it's a minimum because the vertex, which is down here, is the lowest output of the function. And so remember, output is the y value, and so that's the lowest y value of the function. It's called a minimum, all right, or a min point. We can also then take the parabola and we can spin it 180 degrees, and now you have a maximum. Now you have a maximum because, again, the vertex, which again is up here, is the max or highest output of the parabola. Also associated with that vertex is a line of symmetry. And again, if I drew this perfectly, they would be mirror images. They would be symmetrical. So you have a line of symmetry as well associated with your parabola. Now it is possible for the parabola to open to the left or even to open to the right. Those are all possibilities. Another thing about a parabola, and we're not going to deal with it here, is the idea of a focus. So parabola has a focus, and you see a lot of dishes, that radar dishes and satellite dishes. And so satellite waves would come in and they would bounce to the focus. You see that focus in those radar dishes. So anything coming in would hit that curved surface and would bounce right to that focus. So just an aspect of parabolas. Okay, so let's get right into then the aspects of learning how to graph them. So the most basic is y equals ax squared. Y equals ax squared. Pretty simplistic. All right. Remember, the a value controls the relative width of the parabola. Also, if the a is positive, it's a min, like shown here. If the a is negative, it's a max, so it would spin 180 degrees. All right. So, oops, didn't mean to do that. All right. So let's see if I can get selected here. And so the vertex of this is 0, 0. The vertex of this parabola is 0, 0. If we were to write it completely out in the normal way in graphing form, it would be y equals a times the quantity x minus 0 quantity squared plus 0. And again, we don't write it that way, but that's what would be the case. All right, so let me show you the graph here. Let's do this one first. So what if we had just y equals x squared? So the a value is a positive 1. So we're going to have a minimum, and it's going to look just like that, y equals x squared. So we've got a minimum because the a is positive. It's 1, so this is kind of the standard width, and you can see the shape there. And an x value of 1 gives you an output of 1, and x value of 2 gives you an output of 4, x put a negative 1, etc. You can see the line of symmetry, and you can see how it's symmetric. Okay, so what happens then if you had a negative? So what would happen with a negative? So what I'm going to do is just take this parabola here. I'm going to trace it. Okay, and then grab it, and we'll just spin it around. See, it's the exact same width because the a is a 1, right? So the width has not changed, just the fact that it now opens down instead of opening up. All right, so that would make it a max if you had a negative out in front. And then the last thought here, what if you had like a 1/4 for the value of a? Now again, this is a minimum because the 1/4 is positive, but it's going to make the parabola wider. Some like to say flatter. So, and that's actually this one right here. All right, because now when you have a 1 for the x, you get 1/4 output. When you have a 2 for the x, you get a 1 output, right? And you should see that point right here, right? And the line of symmetry right there, etc. And you can keep going and see all the different points of how that parabola works, all right? So again, learn the first one. Why is the vertex 0, 0? Because technically what we have here is x minus 0 quantity squared plus 0. And so vertex is at 0, 0.